guys, we're going to do more story problems today, a little bit of a different type. So if we take a look inside here, let's move on to talking about a shopping trip. So kind of another type of story problem that I notice a lot is what I like to call two different shopping trip problems. So it's like you go on one shopping trip and buy some items, and then you go on a different shopping trip and you buy the same items but like a different amount. If something like that happens, your two different shopping trips are kind of describing your two different equations. So number one isn't quite a shopping trip, but it's similar. At a restaurant, the cost for a breakfast burrito, or a breakfast taco rather, and a small glass of milk is $2.10. The cost of 2 tacos and 3 small glasses of milk is $5.15. How much does the taco cost? So again, you can kind of see there, I go one time and I get this item, that item, it costs this much. But then I do a different thing where I buy the same items but just different amounts. So we kind of have this first sentence here, breakfast taco and a small glass of milk costing that $2.10. So one breakfast taco, one glass of milk, kind of an odd combo, but you know, costs $2.10. And then next time I go, or maybe at a different table or something like that, the cost of 2 tacos and 3 small glasses of milk is that $5.15. So now 2 tacos and 3 glasses of milk is $5.15. Now, one thing to think about here is those are the two things that I do not know, the cost of a taco, the glass of the milk. However, I only care about how much a taco costs. So I don't really care about the milk. So if I think about solving this now in kind of a smart way, I might do elimination, and I might eliminate M since I kind of don't care how much it is. So if I'm going to eliminate M here, I'm going to want this to be a -3. So I'm going to multiply everything by -3 and get my new equation below. So -3t minus 3m equals -630. Then I can add those up until I get -1t, no m's, and then -$1.30? No, 15, oh my goodness. And then I just divide the negative away, and so now I know right now that the cost of a taco is $1.15. So really reading carefully about which variable they care about will save you time. If I had gone through and solved for m, I'd then have to plug it back in to solve for t. And if I'm trying to solve things quickly and efficiently, that wastes some time. Okay, so let's try another one like that. Chase and Sarah went to the candy store. Chase bought 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. Sarah bought 2 pieces of fudge and 10 pieces of bubble gum for a total of $3.60. How much does a piece of fudge and 1 piece of gum cost? So this time they do want to know both, like fudge and gum. And those are both my variables, like we talked about yesterday. So like those are my 2 unknowns. We'll go like F for fudge, G for gum. And here I have like 2 different purchases. So we're going on that little shopping trip, and we have that Chase is getting 5 fudge and 3 candy, or I'm sorry, 3 gum for $5.70. So like 5 F's and 3 G's for $5.70. And then Sarah, on the other hand, was doing 2 F's and 10 G's for $3.60. So she bought a different amount of the things, 2 F and 10 G's for $3.60. Now, actually looking at this one to decide how I'm going to solve, I don't know. I don't love either. Like trying to solve by substitution doesn't feel great because of all the numbers in front of the letters. Like, so eventually I'll have to divide, and if I divide, I might get uneven things. But also neither of these eliminate pretty quickly. But I do think that is what I'm going to do. I think I'm going to eliminate just because then I get to multiply by things, and so I won't get uneven amounts. So I'm going to multiply the bottom by a -5 and the top by a 2, because then I'll have a 10 and a -10 right here. So if I take this top equation and now double it, we'll have 10f plus 6g equals 1140. And then on the bottom, if we multiply that by -5, we'll have -10f, -50g equals -1620. Oh my goodness, I should double check that, but I don't know where my calculator is. Just kidding. Let's just double check that. Sometimes my morning math brain is not to be trusted. Oh my word. Oh my word. Sorry, fast forward, ignore this. What am I doing? 360 times 5. See, $18. It would have been a real bad time for us. Let me just double check the 570. I'm not as concerned. Okay, yeah. Okay, so -18. You all probably knew that way before me. Good job. So now if I add these up, I'm not going to have any F's. I'm going to have -44g equals, so the 1140 minus the 18 is going to be -660. And so then we'll divide by -44, which I was a little bit concerned because that was like a real big negative number, but the negatives will divide out, so I will end up with a positive price for the gum. It's 15 cents for each gum. And that kind of makes sense. Like, gum's not expensive. And then we also want to go back and find the price of a piece of fudge. And so I could use any of the equations I created or any of the original ones. I think I'm going to go with that bottom one because the number in front of f is smaller. Also, multiplying by 10 is easy. So 2f plus 10g, however, I know that g is 15 cents, equals 360. So 2f plus $1.50 equals 360, and we'll subtract that $1.50 for 210, and then split that in half for $1.05 for the fudge, which also makes sense because that would be more expensive. So there we go. Trying another set here. If we look at the old guess my number, this is a fun little game to play with somebody where you can come up with two mystery numbers and sum them and difference them, subtract them, and get like their sum and their difference. And knowing just those two things, you can figure out what the mystery numbers are. And that's because I can write an equation for it. The sum of two numbers means that I'm adding up two numbers. I don't know what they are, so I call them x and y. And I got 18 apparently. Those same two numbers have a difference, so I take the same two numbers, but now I subtract them, of 12. And this is set up perfectly for elimination because the y's will just cancel right now when I add. So we get 2x equals 30. So one of my numbers is 15. And because I know the sum of the two numbers has to be 18, I know the other number has to be 3. And that also gets me a difference of 12. So I can kind of magic that other number just by thinking about it. It's not really magic. You're subtracting in your head. Good job. Okay, let's try another one like that. So the sum of two numbers is 42. Their difference is 30. Find each of the numbers. Always set up perfectly for elimination there. So you get 2x, no y's, 72, So x is 36. And because they're difference, this for me is maybe easier for difference. I feel like that has to be 6, and then if I add those up, that's also 42. So there you go. Now, sometimes it's not set up that way. It's going to use a little bit more mathy language. So it's important to read your story problem really intentionally, really slowly to interpret every single word into a math symbol. So the sum of two numbers is 15 less than twice the first number. Already sounds like gibberish. Their difference is 5 less than twice the second number. I have no idea what's going on here. However, if I read real slow, I can start translating this into math. The sum of two numbers. So sum of two numbers we just talked about. I'm going to add those two numbers up that I do not know. And then the word is such an amazing equals word. Is, that tiny little thing, always means equals. 15 less than. Now that to me sounds like subtraction, and it is. However, it's this special sort of subtraction where I can't put 15 minus. I actually have to put minus 15, and something is going to go in front of it. So 15 less than whatever twice the first number is. So twice the first number means 2 times the first number, which I just happen to call that x, and so that's what you're going to call it. The next sentence starts a new equation. The sum of two numbers, now their difference, so same two numbers, but now the difference, so we're subtracting, is, so that really good equals word again, 5 less than, so that sneaky subtraction, twice the second number. So twice the second number now. The second number that I wrote down was y. And there you go. You have two equations. You have two variables you can solve. And it seems like I'm set up perfectly for elimination. However, we have x's and y's over here that are kind of goofing the things up. So I think on this top equation, I'm going to subtract this x over to adjust this equation. So we have y equals 1x minus 15. And over here, it feels nicer to kind of add the y. So x equals 3y minus 5. And so what I can do now is in place of x in that top equation, I can replace what it equals. So substitution here. And we'll have y equals x. However, I know that that's 3y minus 5. And then minus 15. So I'm going to subtract my 3y for negative 2y, combine my like terms for negative 20, and so y is 10. And then pretty simply, I can plug in the 10 right here and get 30 minus 5 to figure out that x is 25. I think for now, I'm going to skip the randoms, and let's talk about perimeter. Okay, so our final one that we're going to talk about in this video is perimeter. And basically, if we have a perimeter type problem, it's talking about a very specific type of problem involving the perimeter. And perimeter just is always going to use this equation here. So perimeter equals 2L plus 2W. If you look at that, the L is length, the W is width, the P is perimeter. That's one too many variables for what you need. So they're going to have to tell you about one of those numbers. Like they're going to tell you something there, but it's always going to come back to this formula. So the perimeter of a rectangle is 84. Oh, so they straight up told me the perimeter is 84. So I can kind of write 84 in for P. And I found that by doing 2L plus 2W. Now maybe I know what L and W is. I'm not reading this fully, and I probably should have, but next sentence says the length is 2.5 times the width. Find the dimensions of the rectangle. So they kind of told me what the length was, but kind of not. What they did say was the length is 2.5 times the width. So because they kind of told me what the length was, I can plug that in for length right here, and I'll be able to solve because we'll have all W's. So we'll have 84 equals, I'm going to change this 2.5 to 5 over 2, like a mixed number. So 2 times 5 over 2W plus 2W. And that actually works out really nicely because the 2's will divide out. And so we'll have 84 equals 5W plus 2W. So 84 equals 7W. And then I can divide. So W equals 12. So that tells me that the width of the rectangle is 12. And I also know that the length is 2.5 times that, so that 5 over 2 times 12, which I can cross cancel and get that the length is 30. Okay, so another one to try like that. The perimeter of a rectangle is 76. So just like the last one, we're going to put 76 in for P. And we'll have 2L plus 2W. Next, they say the length is 2 centimeters more than twice the width. So really, using the perimeter problem, it's a lot like the guess my number problem where I really have to read carefully because the words are telling me the math symbols I need to be writing down. So like the second sentence here, the length is 2 centimeters more than twice the width. So again, really just like the last one, now I can take this and put it in for L. And so we're going to do substitution. So 76 equals 2, but in place of L, 2 plus 2W plus 2W, and then we just want to be careful that we distribute. So 76 equals 4 plus 4W plus 2W. Kind of at the same time, I'm going to subtract the 4, so 72, and combine like terms. And so W is 12 again. That's weird. That was not on purpose. And then I can find length by taking W, plug it in here. So twice that is 24, plus 2 more is 26. So kind of that second number is usually pretty quick and easy to find. Don't need to do it in my head, or I don't need to write it out so much because I can just think about it. And so then the last one like that, the perimeter of a rectangle is 62. Same jam. 62 equals 2L plus 2W. Ooh, I'm going to do this one a slightly different way. The length of the rectangle is 1. Okay, so length is 1 more than twice the width. So another trick that you can do, looking at the perimeter, all of the terms, so like all of the individual numbers, are divisible by 2. So kind of like with elimination, when I multiply a thing all by the number, I can divide a thing all by the same number. And that's maybe kind of nice to do here because then it just makes my numbers smaller. And smaller numbers are just kind of nicer to work with. So I can divide that whole thing by 2. I could have done that in both of these as well. But I mean, I didn't. And so I'm going to do it now. And then I'm going to take L that I know here and plug it in for L. So I'll have 31 equals 1 plus 2W plus W. I'll subtract that 1, so 30, and then combine like terms for 3W, so W is 10. So it's kind of nicer to work with smaller numbers. And then because I know the length is 1 more than twice the width, I'm kind of taking that 10, plugging it in there, and getting that the length is 21. So there you go. I'll see you on the next one.